Lesson 8.1, we're going to review a couple things you've already talked about in geometry. They should be review for you. The midpoint and distance formulas, and then how to use them. The midpoint formula, we'll find the midpoint of a segment, or the middle point of a segment. And basically what the midpoint formula says to find the midpoint is add your x values. So right here we're adding our x values and divide by 2. That'll be the x coordinate of the midpoint. Then add your y values and divide by 2. That'll be the y coordinate of the midpoint. So if we look at an example here using that formula or applying the formula, this is a word problem example. A landscape design includes 2 square flower beds and a sprinkler halfway between them. Find the coordinates of the sprinkler if the origin is at the lower left corner of the grid. The centers of the flower beds are, so we're looking at, there's the flower beds. The sprinkler is going to be halfway in between them, or at the midpoint of those segments. So notice what they do right here. They add their x values, so 4 and 14, so 4 plus 14, which is 18, divide by 2, so 18 divided by 2 gives 9. And then if they add their if we add our y values, notice our y value is 5, and our second y value is 13, so 5 plus 13 divided by 2, and that equals 9. So we end up getting the same x and y coordinate there, 9, 9. The distance formula will calculate the distance between 2 points. It's really derived from the Pythagorean theorem. It's a square root formula, and this is the actual formula here for distance. It's a big square root, and inside the first set of parentheses you take the second x coordinate, subtract the first one, then you square that result, and then add on inside the second set of parentheses the second y coordinate, subtract the first y coordinate, and square that, simplify it, and take the square root. It's really derived from the Pythagorean theorem. If you can imagine drawing in a right triangle, basically this right here is the difference in the x values. This length right here in the right triangle is the difference in the y values. So that's those two things. We square them. Okay, so that's really like a leg squared plus a leg squared, and then we take the square root of that to find the hypotenuse. So that's what the formula is really derived from. So if we look here, just given 2 coordinates, -3, 6, and 4, -4. Just be careful with the negative signs. They have the work shown here, but I'll go ahead and calculate it out. So it's the square root of, we're going to take the second x coordinate, which is this value right here, inside parentheses 4. We're going to subtract off the x coordinate from point A, which is a -3. We square it. And then inside the second set of parentheses, we take the second y value, which is -4. That would be this y value here. We subtract the y value here, which is 6, and then we square it. So 4 minus a -3 ends up being plus, so that's really 7 squared. This is going to be -4 minus 6 is -10 in parentheses squared. And make sure you use parentheses properly. So that's the square root of, we're going to get 49 plus 100, which is the square root of 149. And we're going to leave it in simplified radical form. And actually there are no perfect square factors of 149. So that is your answer. Sometimes you can find the approximate also, but I think it's best to leave things in simplified radical form. This is just an application problem. Multiple choice. Which point is farthest from -1, 3? If we're talking farthest, we're talking about distance. So we're going to use the distance formula Okay, basically 4 times. They calculate the distance, negative 1, 3, to each of these points. Okay, and I'm not going to go all the way through this, but you can see here's the distance formula from negative 1, 3 to the point 2, 4. So you can see they do 2 minus a negative 1 squared, 4 minus 3 squared. So they get 3 squared plus 1 squared, so that's 9 plus 1 underneath the root, square root 10. And they do the next one. Negative 4, 1. Again, 2, negative 1, 3. So they do negative 4 minus a negative 1, which is negative 4 plus 1 right here. That's negative 3 squared. And then they do 1 minus 3, so this y value minus this y value. And that's negative 2 squared. Go through, that would be 9 plus 4. So we get a 13 under there, or square root 13, which is a little longer than the first point. Square root 13 is longer than square root 10. Then they go 0, 5. Again, always relating to the point negative 1, 3. So 0 minus a negative 1 squared, or 0 plus 1. So that's 1 squared here, which is going to be underneath the square root 1. And then they do 5 minus the 3. So 5 minus 3 is 2. 2 squared is 4. So they have 1 plus 4, square root 5. So that's obviously shorter than those other two. And then they do the point 3, negative 2. How far away from negative 1, 3 is that? So the x value 3 minus a negative 1, which is right here, which ends up being 4. So 4 squared. Here we do negative 2 minus 3, which is negative 5 in parentheses squared. So that's 16 underneath the root plus 25. Add those two together, square root 41. So that is the farthest distance. So that would be the point that you would answer, 3, negative 2. So it would be choice D right here. And so those are basically just review, and that would be applying all the distance and midpoint formulas.